So what is a radical equation? It is a radical with an equal sign. So we have already looked at simplifying radicals. So what we're going to do now is take that simplification one step further, and we are going to solve them. So this is where you have to understand the property of inverses, the property of extraneous solutions. So when is an extraneous solution going to occur? It's going to occur if the solution you get does not satisfy the original function. So that goes back to understanding domain and range. We cannot plug a value into a radical that has an even root that will produce a negative answer. You have to understand that to get rid of a square root, you square both sides. To get rid of a cube root, you cube both sides. So to get rid of an nth root, you n both sides. To solve a radical equation, you must isolate the radical. You must isolate the radical, then raise it to that opposite power that I was just saying, and then you solve it like you solve any equation. So if I have the square root of x plus 4 equal to 7, step 1 is to isolate the radical. So I need to get the square root of x plus 2 by itself. So right now the square root is being added by 4. So we're going to subtract 4 from both sides. Thus isolating my radical. So I get that the square root of x plus 2 is equal to 3. So now you want to solve for x. So how do you get rid of something square rooted? You take the square. And then you solve for x. So we get x equals 7. If you think about the square root in its original form, we have x plus 2 underneath. So my domain says that x plus 2 must be greater than or equal to 0, or that x must be greater than or equal to negative 2. Since x is in fact greater than negative 2, our solution will check. You can also check it by simply plugging it in. So you could quickly just go, okay, 7 plus 2 plus 4 must equal 7. 7 plus 2 is 9. Square root of 9 is 3. 3 plus 4 does in fact equal 7. So you can quick check on your own. You can look at the domain, but you do need to go back and check the answers we get with radicals the same way we had to check our answers with absolute values. Okay, in this case, I have two radicals. If you have two radicals, it is impossible to isolate both. So this is going to involve a double square root. So we're going to isolate one radical to start, which we're going to consider to be the root x minus 12. So we're going to have to get rid of both square roots, but it's going to take a process of 2 times as opposed to just the 1 in the last process. So we're going to start by saying, okay, we isolated the square root of x minus 12. I'm going to square both sides to get rid of that radical. That leaves me x minus 12 on the left, and it forces me to FOIL on the right. We're going to combine like terms, but in order to combine like terms, I also want to simultaneously work at isolating the radical. So instead of just combining like terms all on the right side, I'm going to move the x to the left side. I'm going to move the 4 to the left side. So that's going to cancel the x and the 4 on the right side of my equation. It's also going to actually cancel the x's on the left side. So you get negative 16 equals negative 2 square roots of x. Square root's still not isolated, so we're going to divide, negative 4. We're going to divide both sides by negative 4. Now, my radical is isolated, square both sides, and I see that x is 16. And you can always do a quick check. Okay, so then it would fail. So this does not work. It is an extraneous solution. Because 2 does not equal negative 2. So that makes 16 an extraneous solution where you get an answer, but that answer is not valid. A radical is anything raised to a power that is a non-integer. So in this case, we are raised to the 1/3 power. That is the same as saying the cube root. So this problem is equal to 2 cube roots of 6x minus 3 equal to 4. They mean the same. So again, our goal is to isolate the root. So we need to divide those sides by 2. So you have 6x minus 3. You can write it either as the cube root or to the 1/3 power. It does not matter. That is equal to 2. So again, the idea is to get rid of the cube root or to get rid of the 1/3 power. We are multiplying inverses together. So 1/3 times 3 becomes 1. So power to a power is multiplied. So that's why if you have a cube root, you cube both sides because it cancels each other out and you're left with what's inside. So we would have 6x minus 3 equal to 2 cubed, which is 8. Add 3, divide by 6. And again, do a quick check. And we get that 4 does in fact equal 4. So we are happy. A 4th root is like a square root. Your domain cannot be negative. So we are automatically restricted with the solutions that will work for this problem. A cube root has no domain restrictions. A 4th root, like a square root, must have what's underneath greater than or equal to 0. So I am already limited and that all of my answers must be greater than or equal to -2. If I get a solution below that, it is invalid. We're going to isolate and then take our power. So if we have the 4th root, we're going to 4th both sides. And solve for a variable. And again, once we've isolated and solved for our variable, we just need to check to make sure it works. Again, 25 is well greater than -2. We get 75, 6, 81. 4th root of 81 is 3. 3 times 4 is 12. We're happy. not terrible. Most of you at this point are really good at solving. It's the check steps you have to not forget. So the most difficult problem is probably where you have two radicals, just because it involves the double squaring and FOILing. So the ones you want to look out for and check on your homework more carefully.